Hi everyone, I wanted to talk to you about when you draw a Lewis structure and you have run out of electrons and you need to create an octet for an element in that compound. I want to focus on how we fix that. If we don't have an octet, how can we make there be an octet? And what I want to refer you to is this step number 6 on my guideline. Move lone pair electrons around to form double or triple bonds to create octets if needed. You're basically changing in your drawing a set of dots as a lone pair from a non-bonding pair, lone pairs are not bonded, changing it to a bonding pair that is shared between atoms. So an example would be, very simple example, would be the compound molecule. It's not a compound, it's an element, nitrogen, N2. So when you just have two elements, two atoms, there's not really a center to the picture. You just put the two next to each other. You still need to count how many total valence electrons you have to draw into your Lewis structure. So each nitrogen contributes 5. You have 10 electrons total. Start off by drawing a single bond between the two nitrogens. That used 2 electrons. Now you have 8 electrons to place as lone pairs around the outsides. Nitrogen will always follow the octet rule. Always. Carbon, oxygen, nitrogen, and fluorine. Always follow the octet rule. So for this nitrogen, it already has 2 around it. I'm going to start on this side. Adding lone pairs, 2 dots at a time. And I'm going to go ahead and fill in the octet for that nitrogen. 2, 4, 6, 8. So I just used 6 of my lone pair electrons that I had to place. I only have 2 more. So I'm going to put those 2 right there. And now I've used all 8. I've used all 10. Okay. Obviously, I made that nitrogen have an octet, but this nitrogen does not have an octet. You can't add more electrons. You already are at 0. What you can do is, instead of that 2 electrons being a lone pair, it can become part of a bond. And now instead of this lone pair being by itself, it can now be part of a bond. And that is called a triple covalent bond. There are 6 electrons total shared between the 2 nitrogen atoms. And then each nitrogen has a lone pair. Check the octet rule. 2, 4, 6, 8. Yes. 2, 4, 6, 8. Yes. Okay. What about this one? Here's a compound, COCl2. We got different types of elements here. The element that usually that needs to go in the center, really, is the least electronegative element. And if you know your trend for electronegativity, you can recognize that of CO and chlorine, according to our trend, carbon is the least electronegative of those options. So in our sketch, it's carbon in the middle, and then it does not matter in what order you place these other 3 atoms. They just are terminal on the outside. Count up your valence electrons. 4 from carbon, 6 from oxygen, and then each chlorine has 7, so that's 14. We've got 24 electrons to place into this sketch. Start off, single bond, everything to the center. I used 6 electrons. 18 left to place as lone pairs. Lone pairs start placing on the outsides, and then if you have any still to place, you can go to the center atom. 2 dots at a time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That was 12. 1, 2, 3, 4, 5, 6. That was all 18. And then you check the octet rule for everything. This oxygen has an octet. This chlorine has an octet. This chlorine has an octet. That carbon in the middle does not have an octet. And carbon must have an octet. So what can we do? We have to move a lone pair and turn it into a bonding pair. Now, which lone pair are we going to move? Should we move one from the oxygen or one from the chlorine? The answer is to move one from the oxygen. There is a reason why, and it has to do with something called formal charge. If you check your octet rule now, that oxygen, 2, 4, 6, 8, yes. Carbon, 2, 4, 6, 8, yes. Chlorines, yes, yes. Okay, so this is a good Lewis structure, but again, how did we know for sure to move a lone pair from the oxygen atom? If we calculate something called the formal charge of an atom in a Lewis structure, what we are doing is using a little formula. Where we take the number of valence electrons for that element, and we are going to subtract half of the electrons that are bonded to it, and then the number of lone pair electrons. Did everybody catch that? Take the valence electrons for that atom, subtract half of the number of bonded electrons to that atom, minus all of the lone pair electrons. And the goal is to minimize formal charges when possible. So you want the lowest formal charge, such as a 0 if it's possible, maybe a -1 or a +1. Other than that, you probably won't. Well, you can probably rearrange your structure to minimize formal charges if you start having +2s or -2 formal charges. For this example, if we had left the oxygen like that, and we had done a double bond with a chlorine, check the formal charge of this chlorine and of this oxygen. Okay? Formal charge, again, would be the number of valence electrons of oxygen. So valence electrons for oxygen, 6, minus half the bonding electrons. In this drawing, oxygen has 2 electrons bonded to it. So take that number. The total number of lone pairs, 1, 2, 3, 4, 5, 6. That gives a formal charge of -1 to oxygen in this drawing. If we had double bonded the chlorine, what would be its formal charge? Again, we would take the valence electrons of chlorine, 7. Subtract half the bonding electrons. Chlorine now has 4 electrons bonded to it. Half that number is 2. Lone pairs in this drawing, 1, 2, 3, 4. That's a number of +1. -1 and +1. If we do it with the oxygen double bonded, check our formal charges. So I have a double bonded oxygen and a single bonded chlorine. Check the formal charge of oxygen here. 6 valence electrons minus half of the bonding electrons, so -2, minus 1, 2, 3, 4 lone pair electrons. That's a formal charge of 0. Check chlorine. 7 valence electrons minus half the bonding electrons, minus 1, 2, 3, 4, 5, 6 lone pair electrons. That is also a formal charge of 0. This is the structure. Minimized formal charge. This is the correct Lewis structure for this compound.